Hello, my name is Deepak Mewala. I am a third year PhD scholar at Department of Computer Science and Engineering, Indian Institute of Technology, Kharagpur. My research work is related to learning more from less data, which precisely is meta learning based approaches for few short learning setting. And in the past, I have been a student at Neuromatch in computer neuroscience course, and then I have been twice TA in deep learning course, like in 2021 and 2022. And I have been a TA in different MOOC courses and even at my institute's deep learning course as well. But at Neuromatch, the experience is always different. And I also volunteer at Neuromatch Academy, and I am a content developer at Match Academy as well. So let's come to the tutorial. So today we will be learning about Autograd, right? So deep learning frameworks like PyTorch, TensorFlow, Zach have their own efficient and sophisticated set of algorithm for they are also known as automatic differentiation. But in the case of PyTorch, it is called Autograd, right? So why Autograd is that much important? Because in deep learning, it allows to efficiently compute the gradient of the loss function with respect to all the parameters in the computational graph. It is essential for training deep neural network because we need to update the parameter in the opposite direction of the gradient to optimize the loss function, right? But how does this autograde work? This autograde works by keeping track of all the operation performed on a tensor as it moves through the computational graph. And when we call the backward method on a tensor representing the loss function, so Pytorch uses the chain rule of differentiation to calculate the gradient with respect to gradient of the loss function with respect to the parameters of the graph, right? Now coming to, so we'll start with forward propagation and then we'll discuss the backward propagation in the next section. But before starting that, what is the main advantage of autograde, right? So the main advantage of autograde is that it allow us to avoid the tedious and error-prone process of manually computing the gradient using calculus. This is especially important in the case of deep learning, where we have a lot of parameters, like millions and billions of parameters. So can you imagine, like, if we have to manually calculate or write code to calculate manually the gradient of loss with respect to all the millions and billion parameters, it's almost impossible. So this is the first advantage. And another major advantage of autograde grade is that it allow us to experiment with different loss function and optimization algorithm, right? By just simply changing the loss function and the optimizer, we can mm, we can we can train the same uh, model, and then this autograde will automatically calculate the gradient uh, with respect to the loss function or whatever optimization algorithm we are using for all the parameters, right? This is the two major advantage of uh, autograde. So let's start with our exercise for today. And in this exercise, we have to majorly implement this. We are provided with two tensors to build the following graph, and which implement a single neuron with scalar input and output, right? And then, so in this first, we have any init parameter, which will be initializing W and V, and we are converting W and V to tensor with the help of torch tensor. And notice that here we are using require grade is equal to true. So require grade, what does it do? So in PyTorch, it will when we do require grade is equal to true, it it will then start tracking every operation using this tensor while conveying the computational graph, right? And then next we have to implement the forward function. So in the forward function, we have to write for prediction, right? So what is the formula of prediction, right? So here in this case, we have to write like prediction. Prediction is equal to we can uh, that is like we can use 10h of wx plus b, right? So we have to write this here. Let's see how we can write it. So to access torch 10h, we are using torch dot 10h, and then we'll be using x, and then with the help of self, we will access w and then add bias to it. that is WB. Okay, so this is our forward function, and then we have written here for prediction, right? Next, we have to write code for square loss. So first, we have to comment this, and then for loss, we will be using L2 square loss, which we already know, which is y true minus y prediction, and then square of that, right? So let's uncomment all of this with the help of control plus slash, and then now we are removing these annotations, and then let's run this code. Let's run this control plus enter, and then see. Okay, so we have initialized weight with 0.5, that is W, and then bias is 0.5 is the weight, and 0.5 is the bias. And then for x is equal to 1 and y is equal to 7, the prediction is 0, right? So now for the square loss, y true minus prediction, that is 7 minus 0 is 7, and then the L2 loss is 49, that is 7 square, right? So this is the forward operation, right? So here the x value is given, and then the y value is calculated, and the loss is calculated on that, right? Next, we will be discussing about backward propagation. Let's discuss the backward propagation.